Hello everyone, how are you guys doing? I hope you're all doing amazing. Welcome to another video. We'll just look at you first. You're looking especially stunning today. I bet you made some headtones. Well, today our problem is majority element. In this problem, you are given an array nums of size n and you want to return the majority element from that array. So basically, you want to return the element which occurs the most number of times, and it is given to us that the element that will occur the most number of times in this problem is gonna appear more than n by 2 times. And it is given in the problem that all of the test cases that we are going to be given, they will have the majority element which is occurring more than n by 2 times. So that will be taken care of by the problem itself. So there are many approaches of solving this problem. We are going to take up two in this particular video, and the second one is going to solve this follow-up where we want to solve the problem in linear time and using O1 space. So the first solution we are going to go through is going to be linear time, but it is not going to be O1 space. It's going to be linear space as well. So let's go through that solution first because I think it's much more simpler and much more intuitive, and then we can go on to the second solution. So let's take up the second example and go straight to our whiteboard to understand the problem. So in this example, you're given 2, 2, 1, 1, 1, 2, 2, and you finally return your output, which is 2, which is the majority element, which occurs more than n by 2 times. So let's go here. Let's write down our array, which is 2, 2, 1, 1, 1, 2, 2. And finally, you want to return the output, which is your majority element, which is 2 in this case, which is occurring more than n by 2 times. So you can already see that this problem doesn't fall in the same pattern we had been following right now, where we had to update some array elements in place and we finally wanted to return our helper variable, which was somehow using the two-pointer approach. I was already getting bored of this problem, so it's great that we have another kind of a problem today, and let's see how we can go about solving it. So when you think about finding out the majority element, what can be the simplest solution that comes to your mind? So, for example, when you go ahead and do voting in your region, when you're finally shown the results, you're shown the results not as an array of the votes that have been made. You're shown the results as a map in some sense, as a hash map. If you are aware of that terminology in computer science, so basically you have a hash map or a dictionary in Python terms where you have the particular element that you want to know the count for, and then you have the number of times it occurs. And this particular thing is known as a frequency map, and this can actually help us solve this problem. So if we first create a frequency map out of this array, then we can instantly know that how many number of times a particular element repeats, and that will tell us which element is repeating the most number of times, and that's going to be our solution. So to do that, we are just going to iterate through all of the elements in our array once, and we are going to keep a track of them in a hash map in our program, and that way we are going to keep updating the values every time we receive the element of that array. We are going to plus one it. So let's code that up. We will also be introduced to maps in Golang by solving this problem, and then let's go ahead and solve the second solution after going through this one. So, and stay tuned till the end of this video because the second solution is the actual solution of this problem that also satisfies the follow-up. The first solution is just to get a bit more understanding before we go there. So basically what you want to do is you're going to instantiate a map, which is going to be your frequency map. And to instantiate a map in Golang, you want to create a map of the type int. Basically, this means is that you're going to have a hash map which is going to have its key values at integers and its values as also integers. And this is just going to define the type of the map for you. If you actually want to create a map out of it, you will have to use the make keyword. So this is something specific to Golang, and that's how you create an empty map in Golang whose keys are supposed to be an integers and whose values are also supposed to be an integer. And what you want to do next is simply going to iterate your array, which is going to start at 0. Then you are going to go till the length of nums. We have been doing this a lot till now in all of these problems, so this should come very naturally. And then inside of this loop, we are just going to check our frequency map nums or our frequency map nums I and update that by 1. And how can we just do that? Because Go takes care of 0 values for us. So whenever we create a hash map in Golang, it fills it up by default with 0 values. So whenever we try to access any integer from our frequency map, it will be instantiated to its values zero value, which in this case is integer, and the zero value of our integer is zero itself. If we had instead instantiated it as a string, the zero value would have been empty string. So that way Golang always fills in zero values for us. So we can just increment the zero value, and that will take care of the frequency map for us. So we have created our frequency map. Now we want to iterate through our frequency map and see which is the maximum value. So to do that, we're going to write the loop using the range keyword in Golang, which is also a new thing that's we are just seeing for the first time in this series. So basically what we're going to do is we're going to say that our key and value is going to be equal to the range of frequency map. We can use a similar range operator for our arrays as well, which we had not been doing till now. This is going to just allow us to iterate over the arrays the same way we have enumerate in Python. So we can remove this and instead use index comma val in, oh sorry, the Python is leaking up a bit here, and that's going to be it. But we are not going to be using up index, so Golang doesn't feel very happy about it, and we are just going to replace it with an underscore so that Golang ignores it. And so this was just another way to iterate through our array, and we are going to just replace it with our val. This way we don't have to take care of the whole instantiation, condition, and increment, and it just seems much more readable. So you can use this for the previous problems as well. And when we are inside of our frequency map, we want to take care of the maximum value and the maximum frequency, which is going to be, let's say, num 0 for now, and our max frequency is going to be 0. And what we're going to do is we're going to see that if our frequency right now, which is our value, we can replace it with our value as well. So let's say our frequency and our key is our num. So if the frequency is greater than max frequency, we are gonna update our max val to be num. Only I can type, and our max frequency, oh wow, that was pretty bad, to be frequency. And that's it. That's gonna end up with the maximum frequency at the end of the day, and we can just return our max val, which is what the question expects from us. So let's just run this. I hope I have not made any stupid mistake. Oh, we actually get a compile error. And why would that be the case? Oh, because we somehow removed the int from here while I was explaining it to you. Oh, stupid mistake. So let's run this again. Cool. So this is accepted. Let's just submit this one. Cool. The solution is expected and it beats 100% of the people, and the memory efficiency is not that well because we were actually supposed to solve it in O1 memory, but we solved it in ON memory. And why is it ON memory? I hope that makes sense to you. The maximum number of things that occur in this array for this particular problem is ON by 2, because we are given that one element will always occur more than n by 2 times. So the maximum unique number of elements that can occur are ON by 2. So basically the time complexity is ON because we are going through the array, all of the elements, and the space complexity is also ON because we can get rid of this n by 2. It doesn't matter when you are calculating space complexity or time complexity for that instance. And also your time complexity is in some sense O2n because you are first iterating through your array and then you are iterating through your frequency, but it's a plus between both of them. It's not like you're iterating your array each time you're iterating your map, so that's why it's O of n only. Now we want to get to a solution which still has the time complexity On, but the space complexity goes down to O of 1. So how can we go about that? So to do that, we actually need some more observation from our problem. So if you read the problem carefully, we are given that the majority element is the element that appears more than n by 2 times. Now, why would they give us this additional information? Because if we look at our solution right now, it works for any case. Like any case, if you have the majority element, even if it is not greater than n by 2 times, our problem will still return that majority element. So somehow we need to narrow down our solution even further using that condition where our majority element is going to return more than n by 2 times to actually make it more optimize. So that's a general observation you have to see when you are doing DSA, that the more information you are given to the problem and the more information from that problem that you are able to use in your solution is going to help you optimize further, because you are trying to narrow down your problem as much as possible to your particular problem that you are given, basically. So in that sense, what we are trying to do is we are going to use this n by 2 observation to actually simplify our problem. Now, how can we do that? So if we think of this problem as a voting problem, which we have already taken an example of, if we go through this array and ask everyone which value are they, at the end of the day, the maximum number of times we are going to return the majority element, because they will return the maximum number of votes. So if we are doing a voting in that sense and we iterate through this array, at the end of the day, the guy with the maximum votes is going to be 2, because it is always greater than n by 2 times. Now, what does that tell us? So if we go to each person and try to maintain a list whether the frequency has been highest for this person or not, in that way we can actually handle that if it is the majority element or not. Now, what do I mean by that? So let's do a dry run and try to understand what we are trying to do here. Let's say you have the array 2 2 1 1 1 2 2, and you try to iterate through the array asking everyone that which element are they and what is their frequency. So we are going to maintain a frequency and a element for now. And let's say we are going to instantiate it at 1, and the element going to instantiate at our 0th value, so num0, which is 2. And we're going to go from, so we have already seen this one. We say that, okay, if the length of the array is 1, then this is always going to be our majority element with the frequency 1. But we have to take care of the rest of the array. So that's why we are going to start our iteration at index 1, and we are going to ask them what element are they and what is the frequency. So if the element is actually equal to the value that we are at right now, then we are going to keep the element to be the same and we are going to increase the frequency. But in the next iteration, if the element is not equal to our value, we want to reduce the frequency and the element still remains 2, because if we only observe this part of the array, 2 is again the most frequent element, and what that gives us is the fact that frequency still remained above 0. If the frequency would have gone to 0, then our number of 2's would have become equal to number of 1's, which will happen in this case. So if we are in this iteration, our frequency will again become -1, because the element is not equal to the iterating element that we are on right now, and that way our frequencies become 0. And whenever our frequency becomes 0, we want to say that the next element we find is going to be our majority element, because the frequency has gone back to 0. So whatever is this element is going to be our actual majority element. And that way, if we keep iterating through the array, we always keep the majority element inside of the element, because we only update the element if our frequency has gone to 0. And we are going to keep updating our frequency if we see the same element again and again inside of the array, because it is the same, it is just the majority element reinforcing its votes that it's occurring the most number of times, and any element that occurs instead of that majority element is gonna diminish over time, because at the end of the day the frequency will be cut off by the majority element, and in the last you're going to be returned by the majority element if you keep maintain this kind of a frequency and element mapping. So I hope the solution made sense. You can spend a little bit more time on this problem if you don't get it, or let me know in the comments. I'll try to write an explanation down in the comments for you if this doesn't make sense. But let's try to code it up, and maybe the coding part helps you understand the problem further. So we are going to instantiate a frequency which is at 1, and we are also going to instantiate our max element, or let's just call it majority element, at num0. And when we are here, we are going to iterate through our loop starting at 1, and we're going to go till the length of the array, and again increment the same way we had been doing till now. And inside of this array, we want to check that if the frequency has gone to 0, in that case, I just want to update my majority element to nums of I, which is the first element I see after the frequency has gone to 0, and I want to update my frequency to be 1. And if that's not the case, I actually want to check that if my element, majority element that is, is equal to my nums I, then I basically want to increase my frequency by 1. And if that's not the case, then I want to decrement my frequency by 1 also. And finally, I'm just going to return my majority element. So this way, what you are doing is that you always maintain the element with the most votes. And whenever something goes to 0, you see the next element and consider your uh, array from there. So basically, it's just like a game, right? So whenever you're thinking, like, let's say you are playing a game with your friend, and one represents the guy winning it, and any other number represents you winning it. And let's say your friend is a better player right now, and he's always going to win n by 2 times, more than n by 2 times. So what you're going to do in this problem is that anytime that he wins, you're going to have 1. Anytime that you win is going to be 2. And at the end of the day, we know that 1 is always going to be greater than 2 because he's a better player. And what you're trying to do in this way is that whenever he wins, if he keeps winning, you keep increasing his points because he has been winning consecutively. And then if you start to win, you decrease the number of points. So you decrease the differences between your points. And that way you bring it closer to 1. But whenever your points become 0, so let's say you had win another time here, your points will become 0. So that way you have started off from another playground. So it's basically tied down till there. And then you again consider the guy who comes after that, where the frequency becomes 0, as the majority element, as the majority winner in this case. So I hope this analogy makes sense if you think in this direction. And that should be our solution. Let's just try to run this and see if it is working or not. If we have not made any silly mistake again. Oh, we get a wrong answer. That's interesting. That shouldn't have happened. Why would that be the case? So our output is 1 in this case, where it should have been 2. So let's quickly try to understand what have we done wrong. This makes sense. So this also makes sense. And if our frequency becomes 0, we make this to be num psi, and we make our frequency to be 1 again. So that all seems to be correct to me. Now, what is it that we are doing wrong? So let's try to dry run our code itself. It's a good class into debugging itself. If you face any problem like this, how can we actually deal with this? So you have your 2. So your frequency is going to be set to 2 initially, and your this is going to be 1. So you go inside of the loop, your frequency is not equal to 0, so you don't go here. You go here, and you see that you started at 1, and your num psi is equal to your majority element. So you say, cool, I'm just going to increase my frequency. So your frequency is now going to become 2. And now you are at third element, which is 1. And you go again inside, and you see your frequency is not equal to 0. And you see here that your majority element is not equal to your num psi. So you are in the else case, and you're going to decrease your frequency. So your frequency is again going to become 1. And then you come in this case where you are at 1, and you see that your element is again not equal to your num psi, and also your frequency is not equal to 0. So you make it 0 this time, you decrement it by 1. You're in here now, and you see that you have 1. So, and your frequency is 0. So if frequency is 0, we basically want to convert our majority element to be num psi, and also update our frequency to be 1. Oh, I just found the error. So this should be in else case. So if frequency is equal to 0, we don't want to do anything else. So let's just put everything else inside of our else condition. So we were basically updating it twice in the case the frequency was 0, and that's why we were getting 1 as our maximum value, because the frequency became 0 in the case of 1, and we were never able to replicate it because there were only 2 2s left, and we made 2 1s here. So we never get to the case that 2 will be updated to 1. So let's run this again. It should work this time. It is working. So I think it was a small class into how you debug your code if you're facing an error, whether in an interview or in an OA round. Let's just submit this now. Everything should be working, hopefully. Cool. So this is your solution. We had scrolled down a little bit, but yeah. So you again beat 100% in runtime, and in memory you beat 70%. It's still not the best kind of feeling because we were already beating 50% with our map solution. But at least we satisfy the condition that the problem has given us in the follow-up, that we solve it in O1 time and O1 time and O1 space, because Now you're just using two variables and they are not incrementing with your length of nums. So I hope that solution made sense. See you next time. Bye bye.